I'm going to make a key for this Google Maps assignment, and my directions will be from Niles North to Niles West. And Niles West is here. It was having me take Grosse Pointe, which I was trying to avoid because I didn't want any diagonal streets. I don't think we're there yet, so I did all straight north-south or east-west streets. So you can see how this is just pretty simple. It's a simple route. It's probably not the most efficient route, but we're going to make this work. I also moved Niles West from somewhere over here to this location. Okay, and this is actually how I go to Niles West. I just take this driveway. I don't go all the way south of Oakton to get to this entrance over here. Okay, so I'm going to answer these questions as if I was a student, and hopefully this helps what you did, and also hopefully it helps me see any discrepancies that I did not expect on this. So I'm going to do everything in kilometers, and I wonder if I could change that here. Okay, so here I'm in kilometers. So that's what I'm going to keep it at for this instance. Okay. I'm going to right click on stuff to make sure I get the distances, and I'm going to start right here. Oh, this is my example, and this gave me a different route. Either way is good. And you know what? It should be the same exact answer in terms of displacement. So the first street is Lawler. So I'm going to right click here, measure distance, and get it to this. And that gives me a distance, it's right down here, of 493, which was different than actually I got before. So I'm going to do 493.57 south. And that's Lawler Avenue. Okay, now I'm going to unclick that. And I'm going to start here. I'm going to do my distance from here to Skokie Boulevard. And that gives me a distance of 491.75. I'm just going to copy and paste. Okay, and that's Gulf Road. And that's what it was. And I went to get from this point to this point. I had to go east, so I have to make sure I write east. Okay, I'm going to unclick that. And I'm going to go from here. I'm going to right click distance to here. I'm going to zoom out a little bit. Okay. And now I'm going to take this entire street in one grab. Okay. And I realize it's kind of diagonal right here. And I'm just going to worry about the north-south for the sake of this activity. Okay, so that's 2 miles, but that's 3.22 kilometers. And that is straight south. So that's Skokie Boulevard, and that's this distance south. Now I'm in kilometers here, and before I was in meters, so I got to be really careful about when I add all these up. Okay. Okay, so let's go back up and unclick the first dot or the first measurement. Then I'm going to go from here. I'm going to right click distance to here, and I'm just going to do that. 2.06 kilometers. Okay, and that's Oakton. Oakton Street, and I was going west for that. And I guess I'll take it into the driveway. Okay, so I'm going to start this, right click distance to here. Oh, I don't know what happened there. Okay, right click distance to here, click that, 46 meters. Okay, so I'm going to make a new row, insert row below, whoops, insert row below, driveway, and that's going south. Okay, I think I'm going to convert this right here to meters. So that means I would have to move the decimal point 3 spots to the right. What did I I just do? Okay. Okay, 3 spots to the right, so I'm gonna add a 0. And then get rid of this K. Same with this one, 3 spots to the right, I'm gonna add a 0 and get rid of this K. Okay, so now I'm gonna add up all my south distances. So for the sake of showing you all my work in this screenshot, I'm going to add up my 493.57 plus 3,220. And that gives me 3713.57 meters south. And I'm going to follow my directions and delete everything in red. And then I'm going to add up my east-west. Okay, so now I have some going west and some going east. So I am going to say, okay, well, overall, most of it's going west just by looking at these numbers. So I'm going to, instead of calling this west, I'm going to call this like a positive number. So again, in this class, left is positive, right is, actually left is negative, right is positive. So, whoops, I'm going to call the west, since that's kind of like left when we all look at our screen. This is negative, okay? And I can delete that west. And then I'm going to call this positive, okay, and not worry about the east. So I have negative 2060. That's negative. I don't know what I did here. Okay. I'm going to say 2060 negative plus the 491.75. And this is my value. And remember, negative means west. So I'm going to write that value in, and instead of writing that negative sign, I'm going to make sure I write west here. Okay, hopefully that wasn't too confusing. And because I want this to be, you know, I want it to say the direction still without the positive and negative, because we don't really want to think about that just right now. So I'm going to say this was east and this was west. And I'm going to get rid of these negatives and positives. Okay, so these are my values for the north-south length from Niles North to Niles West. And these are my total east-west lengths. Okay, hopefully that made sense to you. Okay. Find the length of the total distance from point to point from Niles North to your house. Okay, so I'm obviously doing Niles West. So I'm going to zoom out of this, and I'm going to right click on Niles North, distance 2 here. Okay, so that's the distance. And it says 2.0 miles, or it says 4.08 kilometers. And take a screenshot. Okay, I guess I'll do that since I'm doing all of this stuff. Okay. I want to make sure I get my distance in, so it's actually a good screenshot. Copy and paste that, put that here. Okay, I'm going to shrink that down because I feel like that's a lot of space. Okay, find the x and y components by forming a right triangle. Okay, so I'll do that. So my right triangle would mean that, whoops, distance 2 here to here. I don't know, is that straight? Okay. And then and remember, I think this thing adds up everything. So you got to make sure that you didn't add everything up on accident. So let me go backwards here. I'm going to try to get rid of everything. Let's see. Okay. So I'm going to measure distance. I'm going to try to unclick this. Oh my goodness. Okay. I'm going to try to click this and say measure distance. And I'm going to go straight down. And this is my vertical distance of my triangle. Okay, and I'm going to copy this number down. It's 3.69. Okay, that's 3.69 south. And then I'm going to start from here, distance to here, and go from here to here. And that is 1.38 kilometers east. Okay, and then I want to go back and do my triangle again. And I'm going to take a screenshot of this. Although actually, now that I'm thinking about this and doing this, I don't know how much value is in this step because this value is like all added up. And really it should show, I guess it kind of, no, it doesn't really show. I wish it showed the sides, the lengths of each part of the triangle, which it doesn't, I don't know. So I'm going to replace that, put that right here. Okay. And then total displacement length. So I'm going to go back to this map. I'm going to undo some of this. Let's see what I can undo. Okay. I'm going to start at Niles North, distance to here. I don't know why. Okay. And that should be my distance. So that's 3.94 kilometers. That's my complete displacement length. Okay. And the distance, I guess we did look at this. And the distance says, what does it say? 6.3 kilometers. That's the total distance because that's like taking everything in blue and adding every single thing up. Okay. So I'm going to skip this. I'm going to go back and see if I was close with my table. So the total north-south length was this value. Okay, I'm going to take that and I'm going to put that right here. So I was really close. Okay, so this, by the way, if I move the decimal point and make this meters, I want this to be in meters. I'm going to just add a 0 here and move this decimal point. So that's about 3,700 meters, and that's about 3,700 meters. So that's really good. Okay, and then I'm going to go up and I'm going to grab this value, about 1,500 meters, and drop it right here just so I can compare the numbers. So I was a little bit off with this one. Again, there should be a 0. I'm going to get rid of this decimal, and this is in meters. Okay. So, and this is, why does it say west? Oh, this should say west. Because I went west overall. I went from Niles North to Niles West, so I was actually going west. Okay, so these numbers were a little bit off. Obviously, when I grabbed things, it wasn't completely perfectly straight, but overall, it should have been very close. These two numbers should have been identical, and these two numbers should have been identical. Okay, so I'm going to do one last thing, and that's do the meters per second. So I'm going to take my calculator again, And 20 minutes, by the way, 20 minutes, if I wanted to convert that into seconds, that's 20 times 60, 1200, okay? So 1200 seconds, by the way. So if I'm looking for speed, I'm taking distance over time. My distance was this value right here. I'm just going to convert that in my head to meters, so that's 6,300 meters over 1200 seconds. So that gives me a speed of, so 6,300 divided by 1200, 5.25 meters per second. And then to get my velocity, I'm going to take my displacement. And by the way, when you do this, you should be showing work like I am right now. So again, I want to keep this in, whoops, let's do 3940 meters. Meters, not meters, over 1200 seconds. Okay, so 3,940 over 1200, 3.28. Okay, so there's my work. I do want to talk about this value right here. This value should have been, if I did the Pythagorean of all of this, that triangle, let me just show you that screenshot. If I did the Pythagorean of this triangle, I should have gotten a squared plus b squared equals this hypotenuse squared. And those values are, this is a squared, b squared equals Pythagorean, or my displacement squared. Okay, what's the distinction between distance and displacement? Check your notes. Distance is total path traveled, and displacement is as the crow flies. It's, if you were a bird, what path would you take? You would go straight up from A to point B. Okay. Can the magnitude of displacement ever have a larger magnitude than distance? No, it cannot. Your final position minus your initial position will be the shortest possible distance. Well, ships and planes do not have to follow streets and roads. So typically they would use displacement vectors as long as air traffic and sea traffic allows it. Okay, well, hope this helps. Please let me know if you have any questions, and feel free to go at fast speed on this. Obviously, you would delete all the red stuff because the directions say to do that.